because I do want to show you this one. It was going to be in the video, but it got a little convoluted. So I pulled it out because I think I could have gotten there, but it kept getting longer and longer. So I did work it out. I went through it again this morning and figured out the best way to do it. I didn't want to do it this way, but it is still the best way to get to the answer. Because again, we have to get rid of that double angle. Now, if the cosine wasn't in this problem, that'd been fine. We got it, the tangent of 2x by itself, saw what value inside of tangent would have made the function equal that value, and gone from there. But because of this 2 cosine of x, we're going to have to use our double angle formula. In the double angle formula, it's not 2x because that would get us nowhere. 2 tangent of x over 1 minus tangent squared of x minus 2 cosine of x is after putting in the double angle formula. Now it helped us some because now we don't have tangent of 2x, we just have tangent of x, but we have it in 2 places, which doesn't help us much. But there is one thing we know about tangent. It is sine over cosine. So we're going to replace it with sine over cosine. Because I was really trying to avoid having this fraction inside of a fraction. So last time I tried doing this was multiplying through by 1 minus tangent squared of x, which would have got us there, but it ends up giving us more fractions that we have to try to see if it gets a little complicated a little quick. Now, one thing I want to do is, get a highlighter for a second, is simplify this here. Because we have fractions inside of fractions, we need to rationalize this so that we don't have this. So, one thing I'm going to do is multiply this whole thing by 1. It's going to be a fancy version of 1, but it will be 1. Now, well, I'm going to do that, but before we do that, I do want to do some simplifying here because I realize we haven't simplified the denominator. And all that is that our 1, the sine over cosine squared, is going to be sine squared over cosine squared. I could have put that in originally, because if tangents, when we have tangent squared, it's going to be sine squared over cosine. Because when we have tangent, it's just sine over cosine, so the power is applied to both. So I could have skipped that step here and just squared it. The numerator, when we multiply by 2, it is just applied to the numerator. So we have 2 sine of x over cosine of x. Scoot him over just a little bit. Minus 2 cosine of x is equal to 0. Now to simplify this fraction, we're going to multiply by the least common denominator. We're going to multiply the top and bottom of the fraction by something that will make the fraction simplify. Because if we look at the fractions inside the fraction, the top one does have cosine of x. So we are going to multiply both by cosine of x. Because if we multiply the numerator's fraction with that cosine, the cosine and cosine would cancel, simplifying that out. If we look at the denominator, multiplying the cosine squared by, so well, sine squared over cosine squared by cosine would remove one of the cosines in the denominator, but it won't remove both. So what we have to multiply, it's not by just cosine, but cosine squared. Because since there's 2 in the bottom, we need both. Does that make sense? So when we multiply this here, the numerator is single fraction. It does work out kind of nicely. Because this one of these will cancel out with this. We do still have 2 sine of x, but since it only canceled out with one of them, we do still have the cosine of x. So the numerator becomes 2 sine of x cosine of x. Questions on this here? I'm going to explain the thought I just had in a minute. I'm kind of frustrated I didn't have this thought a while ago, but it is what it is. Now, the denominator, we can multiply through by the cosine squared. Cosine squared times 1 is just cosine squared of x, minus cosine squared and cosine squared cancel, leaving us with sine squared of x minus 2 cosine of x is equal to 0. Now at this point here, for us to be able to add or subtract, we need the denominators to be the same. So what we're going to do to get the denominators to be the same is I'm going to multiply our other fraction over here by our cosine squared of x minus sine squared of x over cosine squared of x minus sine squared of x. Now I went on and combined them. I did 2 steps in one because we know we're going to multiply them together. Our negative 2 cosine of x times this fraction. Well, the negative 2 cosine of x is going to multiply with the numerator. Or we can say the 2 cosine of x multiplies with our cosine squared minus sine squared, and then we subtracted from the other numerator, which we did, over our denominator of cosine squared minus sine squared. Questions on this here? Now, luckily, the denominator, this is going to get a little bit simpler because whenever we look at a fraction and we're trying to solve for what is going to make it equal 0, one thing that is nice is that there's no way, because if I have a fraction equal to 0, well, if the denominator is 0, it means nothing, it's undefined. So what that tells us is that sine squared, or cosine squared minus sine squared cannot be 0. And we can solve or check that in a minute. But the only way a fraction can be 0 is if the numerator is 0. So at this point, the only thing we're really focused on is the numerator, not the denominator. So in the numerator, we will have our 2 sine of x cosine of x. And we can distribute the negative 2 cosine through, giving us negative 2 cosine cubed of x plus 2 sine squared of x. Cosine of x is equal to 0. Questions on this so far? Now looking at all this here, there is something that's nice because again, we need two or more things multiplied together to equal 0. Well, all three of these terms do have a 2. And they also all have a cosine, at least one of them, yes? So one thing we can do is factor out 2, about wrote sine, cosine of x from every term. Because if we factor it from the first term, we're just left with sine of x minus, I take 2 cosine away from this, we just have cosine squared of x, plus 2's gone, cosine's gone, sine squared of x is equal to 0. Whenever we have two or more things multiplied together to equal 0, one of them must be 0. So we're saying either cosine of x is 0, or I'm going to rewrite this a little bit. Negative cosine squared of x plus sine squared of x plus sine of x is equal to 0. Now out of all three of these, one of them is nice, and that's cosine of x. It's already equal to 0. The two spots where cosine 0 is pi over 2 and 3 pi over 2. Finish with that one there. The other side. Cosine squared is the same as 1 minus sine squared. Trigonometric identity. Now if we distribute the negative, because we would have negative 1 plus sine squared of x plus sine squared of x plus sine of x is equal to 0. Really what we're saying is we have sine squared of x, 2 sine squared of x, because we got 2 of them, plus sine of x minus 1 is equal to 0. Now this does factor. Since the 1's negative, we will have positive and negative. And then we'll have sine of x and sine of x. Incidentally, the 2 is going to go with the minus 1 because we do need a positive middle term. I will still check this because sine times negative 1 is negative sine. 1 times 2 sine is plus 2 sine, which does give us 1 sine of x, which is the middle term we wanted. Now at this point here, again, we have two things multiplied together to equal 0, so one of them must be 0. Here, we can subtract 1 from both sides, telling us sine of x is equal to negative 1. And the only spot where sine of x is negative 1 between 0 and 2 pi is 3 pi over 2. It's already been listed. Now the other side, we can add 1 to both sides, telling us 2 sine of x is equal to 1. Divide both sides by 2, telling us sine of x is 1/2. And if we look on the unit circle, I believe our two spots are pi over 6 and 5 pi over 6. Yes. So all 4 of our answers are these here. And we could check each one of these here. It does help if it's in radians, not degrees. So it works with pi over 6. We can do 5 pi over 6. We get 0. 3 pi over 2. 3 pi over 2. Like, how did I not get 0? Well, it helps. You actually plug in the right number. We get 0 also. Questions on this here? Now, again, with any of them, I would make sure to get it in all of terms of, especially if we have cosine, get it all in terms of cosine. If you get stumped, by default suggestion would be to try to get it all in terms of sine or cosine. So if it's all in terms of secant, cosecant, get them in terms of sine or cosine. Because sometimes, well, most of the time, it's easier to work with sine and cosine than it is secant, cosecant, cotangent. Cotangent, cosine over sine. Try to get them back in that form. And again, I said there was something I wished I'd have noticed before. Do either one of these formulas look familiar? Either in the numerator or denominator? Look at your double angle formulas. You can have that one. Y'all see it? Because when I was in the middle of solving it, I'm like, the numerator looks very familiar, and it finally, the pieces finally fell in place. Because, as we said at the start of this one, tangent squared is the same as sine squared over cosine squared, yes? So therefore, tangent of 2x is the same as what? Sine of 2x over. I'm not going to work this all the way out because we don't have time and there's not a whole lot of meaning in this, because after this next step, everything is going to follow, is going to be the exact same. Because sine of 2x only has one formula. It's 2 sine of x cosine of x. The denominator is cosine squared of x minus we could have done that in 2 steps. It's frustrating, yes. So again, I would refer back to those formulas for these here. So anything with solving, especially 34 secant squared plus 2 secant of x minus 8. Again, we could solve it with secant, because at this point, I mean, this one here, rewriting it as sine or cosine, I'm going to go on and do this one, and this will be probably the last one we have time for. I would solve it as secant in terms of getting it by itself. Because here, secant is the only term. We don't have others. It's just secant. So I'd factor it. And if you want to use u substitution and set u equal to secant of x and have u squared plus 2u minus 8, that works just fine as well. Since the 8 is negative, our signs are opposite. Now we're looking at the factors of the first and third term. Since it's secant squared or u squared, if we did substitution, it's just going to be secant and secant or u and u. Factors of 8, 1 and 8, 2 and 4. I'm going to use 4 and 2. The 4 is going to be the bigger number. Again, if you're not sure, check it. Check it. Make sure you get the right ones. Since we do have two things multiplied together to equal 0, one of them must be 0. And at this point here, we can get secant by itself. We're going to subtract 4, telling us that secant of x is equal to negative 4. Here we're going to add 2 to both sides, telling us secant of x is equal to 2. Well, secant of x equals negative 4. We can do sine inverse or arc secant, but secant is the same as our reciprocal of cosine, so it's saying cosine is negative 1/4. This other one's saying cosine of x is equal to 1/2. And now the two of these here, cosine of x equals 1/2, is easier to work with because all we've got to look at is the unit circle and see where that's true. Well, one of our spots is pi over 3, and the other is 5 pi over 3. So we have these two here. Now the other one, and I believe the review sheet says negative 1/4. Is going to be arc cosine of negative 1/4, or cosine inverse. As we get this here, and it's not even a rational number. Now, as we see here, we do get a positive number that is, if we think of pi over 2, 1.57. It is greater than that, so it is telling us that it's in the second quadrant. Because our cosine value itself, I'm going to go back to the previous page, is negative. And on the unit circle, cosine is negative in the second and third quadrants. So if we want the reference angle for that, let me get there. To get the reference angle, we would subtract it from pi. Yeah. So to get this here, we would really 2 pi minus to get the other angle, because that's what I was trying to work through, because this angle is what arc cosine of 1/4 gets us. That means there's another one down here, which negative arc cosine would get us here. So if we take that away from 2 pi, it should give us the other angle that we want, which is this here. And we can see that this is true because 2 pi minus cosine inverse of negative 1/4 is this here. And if we take cosine, second answer, we get negative 0.25, which is what we want. On something like that, if you do get that, I'm not going to be too nitpicky, especially for this test here this year. As long as you can give me the arc cosine of that, that's fine. There are some on the test that if you get cosine of x or sine of x equals 4, we know that doesn't work because sine and cosine can't be greater than or less than, greater than 1, less than -1.